I wanted to give you another example of balancing a redox reaction. I'm going to do number 88 out of the book. I'm going to do letter B. Okay. And so the first thing we do is we're going to write down our reaction here. We got oxygen and water plus lead going to lead hydroxide. Okay. So the first thing we have to do is assign oxidation numbers. So elements are 0. So my lead over here is 0 as well. Oxygen is -2. Hydrogen is always +1. The charge on the hydroxide is a -1. So that means everything inside must add up to -1. So this is +1, this is -2, so yes, it does add up to that charge. So now I'm going to erase that, which means then my lead must be a +2, okay? Because I've got 2 of them, right? 2 hydroxides, I mean, so 2 times -1 is -2, so my lead must be a +2, or 2 plus, +2. All right, so I've got my oxidation numbers assigned. Now I have to look at and find out who is being reduced and who's being oxidized. So I can see that my oxygen is going from 0 to -2. Therefore, my oxygen must be reduced. My lead is going from 0 to +2, so my lead is being oxidized. Okay, so we start by writing down my reaction here. So I've got oxygen is my reduction, and then my oxidation is lead. Okay? So let's do the lead one first. Let's do the oxidation. So balance everything except the oxygens and hydrogens. So I'm going to balance the lead by adding lead hydroxide. Okay. My leads are balanced. Now I balance my oxygens by adding water. I need 2 waters. And then I balance my hydrogens. So I got 4 hydrogens on that side. And I have 2 on this side. So I'm going to need 2 H pluses. And then I'm going to balance my charge by adding electrons. Okay, so I've got 2 positive charges, 2 negative charges. They cancel out. Again, the fact that the hydrogens and electrons are equal is a coincidence. All right, now the top, there is no other element except oxygen. So to balance my oxygen, I add water. Okay? That gives me 4 H pluses, so I'm going to have to add 4 H pluses on this side. And then I'm going to have to balance with my electrons, so I'm going to have 4 electrons on this side. The electrons must always be on opposite sides of the reaction. So I've got electrons on the reactant side, I've got electrons on the product side. And now I need to balance my electrons. So to balance it, I'm going to multiply this reaction by 2. So this becomes 4. This becomes 2. That becomes 2. And these become 4 and 4. Now we're going to see what cancels. Your electrons must cancel, otherwise you did something wrong. It's coincidence that the hydrogens cancel. I have 4 waters on this side, or 2 waters on that side, and 4 on this one, so that becomes a 2. And so then we just add everything else up. So I'm going to have 2 waters, oxygen, 2 leads, going to 2 lead hydroxides. Now let's see if we did this right. So we've got, if you want to check the oxygens first, that's probably the easiest way. I didn't do that in the last problem, and you saw what that did to me. So 2, I've got 4 oxygens over here, and I've got 4 oxygens over there. So that's great. I've got 2 leads on each side, and I've got 4 hydrogens on each side, so it's balanced. There you go.